All right, so like we mentioned in this chapter, we're going to be looking at exponential graphs, and this is an example of exponential graphs. We're going to be looking at bacteria growth within a cell. It's just an example, but let's focus on the values and also the graph that comes off it. Also keep in mind what the shape of an exponential graph looks like, all right? Keep in mind what the shape of an exponential graph looks like. We're not going to do the graph paper.
Their content.
There it is.
Bacteria reproduce very simply and rapidly by doubling their contents and splitting in two. Just one bacterium, dividing every 20 minutes, could produce nearly 5,000 billion bacteria in one day.
Now, let's rewatch the video. This time, I will stop the video every second, and I want you to count the amount of bacteria present on the Petri dish at the 1 second interval. First, let's notice that at 0 seconds, there are 2 bacteria on the Petri dish.
Bacteria reproduce.
At 1 second, how many bacteria are on the Petri dish? There are 4 bacteria on the Petri dish at 1 second.
Very simply and rapidly.
So now it's 2 seconds. How many bacteria are on the Petri dish? There are 8 bacteria on the Petri dish.
By doubling their content.
Now at 3 seconds, how many bacteria are on the Petri dish?
You guys should probably keep track of these numbers.
There are 16 bacteria on the Petri dish at 3 seconds.
But she's also going to put it on the table.
Now let's record what we just noticed. We noticed that at 0 seconds, there were 2 bacteria on the Petri dish. At 1 second, there were 4 bacteria on the Petri dish. At 2 seconds, there were 8 bacteria on the Petri dish. And at 3 seconds, there were 16 bacteria on the Petri dish. What pattern do you notice? If this pattern does continue, how many bacteria will there be on the Petri dish at 6 seconds on the video?
I'm going to pause that because I want some of you to send me some answers in the chat. So they continued the table down here. And at 0, it said 2, 1, it said 4, 2, whatever. But what would it be at 4? What would it be at 5? And what would it be at 6? I want you to send me some answers in the chat. I saw your answer, whoever just said that, I saw your answer, but you have to tell me what is that number for? Okay, there we go. Cool, are we seeing the pattern? So tell me what 4 would be, what 5 would be, what 6 would be. And someone tell me in words what is happening each time a second is added. Someone tell me.
It's doubling.
It doubles.
It is doubling. All right, it is doubling at 6 seconds. Okay, cool. There we go. Let's continue.
I want you to take some time to figure that out. So we noticed that the bacteria doubles every second. So if the bacteria doubles every second, then we know at the 6 second mark on the video, there will be 128 bacteria. Did you also notice that sometimes it was difficult to count the amount of bacteria? This is because these are not exact numbers. Because of the way the bacteria is growing and splitting, it is difficult to get an exact number, so this data is discrete.
So now she has it's the same numbers from the last table, and now we're going to plot them. So the x-axis would be time, and the number of bacteria would be the y-axis.
Now, let's graph the number of bacteria versus time in seconds that we just saw on the video. This table contains the data that we just collected from the video. But before we begin graphing, let's make sure our graph is correctly labeled. Our x-axis is labeled in time by 1 second intervals. Our y-axis will represent the number of bacteria. What do you think is an appropriate interval that we can use for the number of bacteria?
I want to pause on that one as well. Can someone put in the chat? Because look at the numbers. Number of bacteria, it goes from 2 all the way to 64. And there's no way that's going to fit on my graph. All right? But I could make it fit. I could go by a different number. Let's see what some people are sending. Some people are saying go up by 2s. Some people are saying go by 8s. If I go by 2s, let me see. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Then I wouldn't get to plot my 64, 32. So we got to go up by double each time. Let's see what she ended up doing. I stopped that video because I want us to realize that we don't always have to go up by ones. We decide what's going to fit on our axes for each axis, and then we want to ensure that whatever we put on there is going to account for all the numbers that we're plotting. All right?
I'll choose 10.
Oh, she went up by 10s.
So now, let's begin to graph what the growth of the bacteria actually looks like.
And I don't want you to think that because she went up by 10s, it means that that's the only correct answer. As long as your graph will account for all the numbers, then you're good to go. So it could have been, let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we couldn't do 4s because that only goes up to 40. We probably could have done, no, we can't do 5s. 7s probably. I think 7s would have worked. So don't, or 8s, yes. 8s would actually be perfect. So don't think because she went up by 10s, it means that that's the only way. At the end of the day, we're interpreting the graph. All right? It just has to make sense. Wait, let's go back to that part. My bad. So she plotted the points. All she did was follow it. So at 0, she was at 2. She estimated where 2 would be. And then she just plotted each graph. So the x-axis is on the left. And then she connected it with the y. All right? So I want us to look at this. So she said at 5 seconds was 64. So 5 and 64 would be around there, right? So then that's where that point is. This is an exponential graph. All right? That right there is an exponential graph. Let's continue.
Now, let's listen to the video again. This time, listen to what the narrator says about how long it actually takes for the bacteria to grow.
Bacteria reproduce very simply and rapidly by doubling their contents and splitting in two. Just one bacterium, dividing every 20 minutes, could produce nearly 5,000 billion bacteria in one day.
The narrator says that the bacteria actually doubles every 20 minutes. So since the bacteria doubles every 20 minutes, what will our new table look like? Let's work through this together. On our new table, we're going to add a column for our new time in minutes. We know from our previous table that at 0 seconds, there were 2 bacteria. In real time, this is 0 minutes. From our previous table, at 1 second, there were 4 bacteria. We know that in real time, this is 20 minutes. We also know that at 2 seconds, there were 8 bacteria. And in real time, this is 40 minutes. And we also saw that at 3 seconds, there were 16 bacteria. But we know that in real time, this is 60 minutes. Now I would like for you to take a moment to extend this table to see the number of bacteria there will be at 300 minutes. Take a second to compare your table with the one that I have completed here. So at this rate, what is the number of bacteria that there will be on the Petri dish at the 300-minute mark?
And we're not going to go through that and work through that, but what I want us to see is that exponential graphs, the y-axis, it doubles. Exponential graphs, the y-axis doubles. And someone asked a really good question in the chat, and I'm going to share it with everyone. So someone asked, exponential graph is graph based off a table, and the answer to that is all graphs can be graph based off a table. All right, after you've graphed it, then you could see the shape of it. All right. Once you see the shape of the graph, then you could determine if it's quadratic, if it's exponential, if it's linear. But what you could also look at, if you look at the y values and you see that it's constantly doubling, you could automatically tell that it's exponential. All right. A lot of times you could just look at the numbers, the y-axis and the x-axis values, and determine what type of graphs. But I could give you a regular table with numbers, and it could turn out to be a linear graph. All right, it could turn out to be whichever. It's just about plotting. And then another person that someone else asked the question. Let's get these questions answered. So exponential graph is the type when the y-axis doubles. Is that the only way you know it's exponential or no? Not necessarily. But normally, yes, the y-axis will double and you could tell. Again, the shape of the graph could tell you if it's exponential. All right. Again, all these different graphs have different shapes. That's why they were given their names. I'm going to end the video right there. If you have any questions about anything, let me know, reach out. The worksheet that we're